the first step we will do is compare with standard form. Okay, so standard form is m dx plus n dy equal to 0. So now this term is going to be m and this term is going to be n, m dx and n dy. So let us write that down. The value of m is going to be y raised to 4 plus 2y, and the value of n is going to be xy cube plus 2y raised to 4 minus 4x. Okay, next we will find out dou m by dou y. Remember, we do it cross. So we differentiate m with y and n with x. Let's do that. So dou m by dou y is going to be 4y cube plus 2, and dou n by dou x is going to be partial derivative with respect to x. So y cube is anyways constant, derivative of x is going to be 1. So this remains y cube. Then y is constant, so this becomes 0, and then this is minus 4. So we have the value of dou m by dou y, which is 4y cube by 2, and the value of dou n by dou x is y cube minus 4. So clearly these two are not equal, and if they are not equal, it is definitely not an exact equation. Let's write that down. Since dou m by dou y is not equal to dou n by dou x, therefore it is not an exact equation, an exact differential equation. That's my first conclusion. The given equation is not an exact equation. Okay. Now, whenever that happens, that your equation is not exact, we know that we have 4 rules altogether, and we can use any of the 4 rules and try to convert that into exact form. Okay. And right now we will look at this dou m by dou y and this dou n by dou x. It's more like trial and error. You don't know which rule you have to use, but you should try the rule 1 and the rule 2. But it is clearly evident here that I should be using rule 2 here. The reason is just try and error. You can just like solve with the first rule, see if it works. If it doesn't, then just go for the second one. Okay. So now let me use rule 2. Let us see what happens. Now in rule 2, we will do this dou n by dou y, this dou n by dou x, this term, minus dou m by dou y. Okay, I'm going to do this minus this, and then divide by m, and let us see what values we get. Dou n by dou x is y cube minus 4, minus dou m by dou y is going to be 4y cube plus 2, and then we will divide this by m. The value of m is over here. We can take this number here. This is y raised to 4 plus 2y. Okay, let us simplify this term. Let's see what we get. This is going to be y cube minus 4y cube is just minus 3y cube, and minus 4 minus 2 will be minus 6. Okay, so once I get this denominator, I can take y common. This will be y cube plus 2. Okay, and let us simplify this further. I can take minus 3 out from numerator. It will be y cube minus, this will become plus 2, and this is y into y cube plus 2. Do you see these two terms are cancelling out? And the answer you're getting is minus 3 by y, and it's very good because we got a function of y. Okay, and as per the rule, if we solve this, okay, and if we get the answer as f of y, which is exactly what we have got here, in that case we can find integrating factor very easily. Okay, that is e raised to integration of f of y. So now let us find the integrating factor. Let me use the space for that. So integrating factor if is going to be e raised to integration of the function of y is here. The function of y is minus 3 by y. So it is minus 3 by y dy. And then that will be e raised to minus 3. I'll take it out. Integration of 1 upon y dy. So this will be e raised to minus 3 log y. And I hope you know this property of log, that this minus 3 can simply be written here. I hope you know this already. Let me write down. A log b can be written as log b raised to a. I hope you know these two are the same things. Okay, so that minus 3 goes there, and then I will get integrating factor if is equal to e raised to log y raised to minus 3. Now e and log, e power log is just going to cancel out, and I'm going to get y raised to minus 3, or I can write it as y cube, that is 1 over y cube. Now we got the value of integrating factor. Okay, now as soon as we find the value of integrating factor, next we find is m dash, which is nothing but m into if. Okay, let us write this step well. The value of m I can find from here. This is y raised to 4 plus 2y. And then when I multiply by if, what is the product? What if I multiply m with if? It is going to be 1 upon y cube. This is the value of if. The if value is 1 upon y cube. And then this will be, let us simplify this a little bit. I can take one y out. So this will be y cube plus 2. Okay, I took one y out from the numerator. So this becomes y cube. This becomes 2. And then this will become y square. Do you understand? One y got cancelled out. Okay, so this is m dash. Next we'll find n dash. N dash is going to be n into if. Let's do the same steps here. The value of n can be found here. So n is x y cube plus 2y raised to 4 minus 4x. This is n times if is going to be 1 divided by y cube. And then this will be, we can just write it like this. This is x y cube plus 2y raised to 4 minus 4x divided by y cube. So we got m dash and n dash. Now look, when we are finding with the help of rule 2 and that we got the correct if and then we multiplied if with n and m. Now we got m dash and n dash. You really don't have to check. Okay, you can straight away write down that this is 100% sure that m dash dx plus n dash dy equal to 0 is an exact equation for sure. Is an exact differential equation. I've written over here that m dash dx and n dash dy equal to 0. If you write down, it is going to be 100% exact. So now let us write the equation in terms of m dash dx and n dash dy. Let's just see what happens. Now m dash is over here. This is the value of m dash and this is the value of n dash. So let me write them. This is going to be y cube by 2, y cube plus 2 by y square dx. Okay, plus n dash is going to be x y cube plus 2y raised to 4 minus 4x divided by y cube dy equal to 0. Okay, and because it is an exact equation, we can directly write down the solution. Therefore, the solution is integration of m dash dx. Here we'll treat y as constant and plus integration of n dy, where n has to be terms free of x. That's like the first type we already know, and that is equal to c. So once we get it in this form, let us integrate this integration and see what we get. Let me clear some space for this. Y cube plus 2 upon y raised to 4 dx, and then this is plus. Now here we're going to treat y as a constant, and then this is plus. Now here we are not supposed to take any terms of x. So only terms of y will come here. So we will not take this term. We will not take this term. We'll only take the middle term here. That is 2y raised to 4 by y cube. This is 2y raised to 4 upon y cube dy equal to c. Now that's answer is equal to c. That's a constant of integration. So since y is constant, this whole thing is going to be constant. Y cube plus 2 upon y raised to 4. And integration of 1 dx is just going to give me x plus. Now this y cube and y raised to 4 just give me y. Then I'll take this as 2 and the integration of y is going to be y square by 2 equal to c. This 2 will cancel out. Let us write down the final answer. Y cube plus 2 divided by y raised to 4 x plus y square equal to c. And this is the final solution of this differential equation. This is the answer. I hope you understood how I used rule 2 and converted the initially not exact equation by multiplying by the suitable integrating factor, and we got the answer.